So, continuing from last lesson, we are going to start looking at another class. This is the public class die, as in like a die, a 6-sided die or 7-sided die. We started talking about this last time. It has two pieces of data. They're both private, which means nothing other than the class itself can access the data. So we have value and we have num sides. Then we have the constructor. Now this constructor does a lot. First off, it sets it to a number of sides of 6. Then it does a random assignment of those sides to its value. So essentially rolls the die. There's a couple of issues with this. First off, not every die has 6 sides. Secondly, rolling in the constructor is kind of silly because we're eventually going to have some way of rolling the die continuously. So only rolling the die here means we're going to have to write code again to roll the die, and we already said that we don't want to repeat code. So you can call the constructor using the this command. So the this refers to the class that we're in. And it's going to send as an argument the 6. So Java says, all right, is there a constructor that has the same name as this class, which is die, and has a parameter of 1 integer? So it looks, and of course, there it is. So now it says if the number size is equal to 4, if number of sides is greater than or equal to 4, then number of sides is equal to sides. So in other words, this just guarantees that it's at least 4-sided die. And we had the argument before that you can have a 3-sided die, but you technically have a 2-sided die if you have a coin. But we're going to go with a 4-sided die, okay? 4 sides, which is a triangle-shaped figure if you've ever played Dungeons & Dragons. But we're still doing this random thing here, where we're rolling the die inside the constructor. So at this point, we have to come up with a way of handling this, because we're going to want to roll more often than just the one time in the constructor. So we need to have another method that's going to roll the die anyway. So rather than using this line of code here, we're going to refactor and write a method that's going to do the roll for us. So there's this method that says value equals the random roll of the number of sides of the die. And in the constructor, we're going to call the method roll. Now notice, we don't have to refer to the class. We don't have to say die.roll. We don't have to say create some type of object, because again, Java knows that it's referring to this class, because there's nothing else to look for. Now you could be really specific and say this.roll. That way it will be very, very clear to Java what you're asking it to do. I'm asking you to roll the method called roll, or to call the method called roll within this class. The default assumption is that if you just use the method name, you're talking about the method within the class. For our purposes right now, that's going to just be true, because we're not talking about more complicated class structures. But in a very short time, we're going to be talking about a class structure that's more complicated, where there's relationships between classes, and there might be methods of the same name. In fact, I guarantee you, there's going to be methods of the same name in classes that are related, and Java is going to get confused as to which method you're talking about. So this way of putting roll right here is fine, as long as you're only talking about a single class. If we're talking about relationships in classes, you might have to say this dot roll to make sure Java is really clear about which roll you're talking about. So we have now refactored this code to include a random roll method as opposed to just repeating this code over and over again. We needed this method anyway. We had to have some way of rolling the die. And by putting that in here, as opposed to just having that command repeated again with that randomness, we've refactored our code. We've made it better. So why do we need to refactor our code? Well, one, I think it's prettier, but that's just me. But it is more efficient. The computer runs better. It's less code for us to write. If you could just call roll. And if you're copying code from one place to another, there's a good chance you're going to make a mistake. If you have a single method that does the action, if there's a mistake, then you know what's in that single method. You don't have to go hunting everywhere in your code to find where that line of code shows up. Suppose you use the random number generator wrong, and it's producing the wrong kind of die. So now you have to go back and fix it everywhere it would show up if you use that line of code, that random generator line of code, individually. Because we've refactored it and write a method that handles the roll for us, if there's a mistake, we only need to go to look at one place. If we decide we want to change it, we only need to go to look to one place. Suppose we want to make sure our roll is less than 2. Maybe we want to allow to have that two-sided die. All of a sudden, we're playing a new type of game that has a two-sided die. I mean, we could play a virtual game that has a two-sided die. That's fine. It's just a random number between 0 and 1 or whatever. So yeah, you could absolutely do that. So you'd want to go ahead and then have access to that roll method to change it in that spot, as opposed to having to worry about finding it everywhere in the code. That's where those comments would show up. You'd have comments saying, this is the line of code that affects the roll of the die, and you have to go back through and make sure you're doing it everywhere. So it prevents mistakes by refactoring your code and only having one spot doing one thing. For everywhere in the program, it eliminates the possibility of mistakes that kind of track through everywhere. So what are we going to do with this? Well, you're going to write the vehicle class. So this is a class that is to simulate a car. But I say vehicle because it doesn't have to be a car. We're just going to say vehicle for now. And the car can move along a 40-block stretch of road, let's say. That's how big the road is. Your class needs to keep track of the location of the car. Where is it on our 40-block stretch of road? Our locations range from -20 to 20. A location of 0 represents block 0. A location of 1 represents block 1, and so forth. If the user tries to move the car beyond, or vehicle, beyond +20 or behind -20, then the location should be maxed out at positive or -20 respectively. So if they try to go to 21, you should bump them back to 20. You need to test your code, so there is a student runner file that allows you to, test this before you submit it. The variables that you have to keep track of, or properties that you have to put into your class, are location. That's it. Just an integer called location. The methods that you have to write, now this time it's from scratch, so you're writing this totally yourself, are the vehicle class, the vehicle method, which is the constructor. It sets location to 0. Another vehicle constructor, which sets the location to a particular number. These two should be related. So in other words, this one constructor should be calling the second constructor by using the this command. So very similar to the die that we just looked at. There should be a forward method, which increments forward 1 block. There should be a backward, which decrements by 1 block, making sure that we don't go past 20 or -20 respectively. There should be a get location, which returns an integer value that represents where the car is, essentially its location. And there should be a toString, which represents the car's location. It should print out spaces for all the blocks from -20 to the car's current location, then print out the @ symbol, and then print out the rest of the spaces so we know where the car is. So find the assignment in Blackboard, or your LMS, depending on what we're using, and the student runner class in the LMS and get started. And remember, never stop coding. So this is the vehicle driver class, and then here's the assignment for vehicle class. Just to remind you, here's the book class and the driver class for book class in case you need to look at that, and of course the notes file on constructors. And then here's also an exit ticket, which you do have to do. So work on the exit ticket as well. Never stop coding.